right, thanks, Boris. Yeah, I hope it's not too cold there in Moscow. All right, bye. До свидания. Now that is connectivity. Here I am in the middle of nowhere, and yet in a matter of seconds I can connect to virtually any telephone in the world, and I don't even have any wires. Now, of course, the telephone industry is a bit ahead of the computer industry in that, but they follow the same path: the local phone exchange, local area network, a long-distance carrier, wide area network, and now a global interconnection network. What we all want are computers that have that same intercommunication power, and it's coming. Today, we take a look at the latest in connectivity on this edition of the Computer Chronicles.
Computer Chronicles has been made possible in part by PC Connection and Mac Connection, mail-order software and hardware peripherals for the PC and the Macintosh, and the Software Publishers Association, providers of educational materials to help manage software. Don't copy that floppy.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and with me this week is Frank Derfler. Frank is editor with PC Magazine and author of the special PC Magazine Guide to Connectivity. Frank, we're going to take a look at something here which I know you're a bit familiar with. This is from AT&T Paradigm. It's the ComSphere 3810 modem, and what's interesting about it, this is a software-definable modem. So, for example, if new operating system software comes along to upgrade this modem, I don't have to buy a new modem, I don't have to buy new anything, I can just do it online through the modem. In fact, let me show you. This is the software version that's in here right now, A020300. Now, what I can do is, let's call setup, and I would just go on my phone book, and that's the number of the update center that I want to go to. I would just go over here and dial. I'm not going to do it really now because it takes a couple of minutes for the download, so we'll just get rid of all of this here for a second, and I'll show you, in fact, what we'd be doing. You can actually pull up a map here to see what we're doing. Here's the world map of all the different places we might be connecting to. We're just in the USA right now, so I'll pull up a USA map. And you'll see here's where we are over here in Northern California. Right now it's showing what this location is over here in Florida. We'll get rid of that and identify ourselves over here. And here's Computer Chronicles. And I would simply go ahead and go through the process. Let's get rid of the map, though, and show you exactly what would be happening. As we come up here, back to this menu, we'll get rid of this here and go back to our series. We see this is the old version. As I execute now and put in the new software, we'll see it updates itself, and lo and behold, we now have new software inside the modem, sort of by magic. Frank, explain this a little bit. Where does this fit into the bigger connectivity picture?
This is one of a new family of modems called V.32 BIS modems, Stuart, that can signal at 14.4 kilobits per second over regular dial-up telephone lines. Now, why this is so important is because these modems typically are digital signal processors. That is, they're computers inside. Many other companies require that you change chips in order to upgrade the software. But AT&T Paradigm allows you to go through the modem itself to do the upgrade. You know, these modems are very important for linking local area networks because they do move data so quickly over telephone lines.
What's the status of LANs right now? How many people, in fact, are in a network?
Well, we know that about 51% of all PCs in business and educational organizations are connected to local area networks. And these LANs in those organizations very often serve as the machinery that helps to gather and to store and to process the information that is the product of those local area networks. But now what's happening is that we need to link those LANs. And linking LANs is a very, very important part of the connectivity business today.
Right. Well, that's what we're looking at, Frank. We'll be talking about connectivity, communications, not only between computers, but between networks. And in many situations, the ideal way to connect networks or computers is without wires. A new company called Tetherless Access is doing just that.
Dwayne Hendricks is developing a wireless metropolitan area network for the Macintosh. He connects the Mac to a radio transmitter through the local talk connector. The transmitter then sends files to a receiver at another Mac location where the signal is demodulated. Hendricks sees his wireless network as a new kind of group wear.
If you look at the trend in computing today, is towards collaboration. Well, people tend to form ad hoc groups, okay? So you don't know where you're going to group next. And so wireless allows you to, at least in the model we're going to go for, to set up ad hoc networks.
The first beta test of the tetherless access network is a link between the San Diego Library System and San Diego State University. The new wireless network will give users at several different campus locations access to a wide range of research materials at different library sites. One potential problem with the wireless LANs is the security of the user's data, but Hendricks says there can be various levels of security built into a wireless network.
By using the spread spectrum technology, the spreading code protects you somewhat, but that in itself is not really enough. There are a number of data encryption standards that could be used to encrypt your data before you send it over the air.
With the rising popularity of portable computing away from the physical wiring of the office, wireless LANs may be the way of the future. For the Computer Chronicles, I'm Maria Gabriel.
Before you can worry about interconnecting networks, you have to first connect your computers into a network. Here to show us how to get started in connectivity is Lori Dayton of Novell and Adrian King of Artisoft. Lori, let's describe the hardware setup. First, we have a little two-station network here with your AST machine next to you. Over here you have a colleague with a compact machine. They're already wired. The software's been installed over there. We're going to go through the process of installing NetWare Lite on this AST, correct?
Right. We want to make mention that the software is all contained on one floppy. What you want to do is decide if a server can share its hard drive and a server can share its printer and a client can use other hard drives and printers. Most machines on a peer-to-peer network will be servers and clients.
Okay.
We're just going to give this server a server name and use the machine name for the server name. It'll copy some files over.
All right, let me ask you, while we're waiting for the files to get copied over, we heard at the beginning of the program, Frank Derfler said that, in fact, a majority of personal computers in business are now networked. Is that inevitable? Are we getting to 100%? Is this the way everyone's going to be using their computer?
Yes, especially small businesses. They want to make wise use of their computer resources, like their printers and their hard drives. And in order to use them and share them, they need to be networked. Also, information location is very important. They don't want to have inventory list and address list all over and doing floppy swaps. They want to have it on one machine with letting other people have access
All right,
to
you've
it.
copied your files. What do we do next?
We want to tell them what kind of network card they installed in their machine or plugged in their machine. We do have a couple of packages, Zircom and Eagle, that package all the hardware and the software that they need together.
So is that the card you have in there?
That's the card we have in here. Also, if they've changed the settings, we always give them defaults so they can just push escape. It's only one more question that they need to answer, and that's if we can put our directory in their path, in their bat file, and modify that. That's the last thing that we need to do for install. We create a startnet.bat file, which will load the software, all the software that we've just installed. Now, the server and the client are loaded. We run the utility, which is a menu utility. It will prompt us to log in. We'll log in as supervisor, and we will be able to see the resources on the other machine. We've got a printer on the other machine that we want to share, and over here is a printer. The way that we share that, we go to this directory to capture a port. Again, we give all default settings. Anything now that's printed on this machine will go to that machine. The same if we want to access the mail list that exists over there. We go to this network directory that has been created over there. Network directory is just a term of what area of your hard drive you want to share. Now if we go to our F drive, let me just show you how to create a network directory, or what one consists of. This is the actual directory on that hard drive that contains files. We give everyone all rights except for perhaps Ray or anyone else. We can restrict rights. So now I just want to show you, if we do go to the F drive over here, we do a network directory list.
And you were just looking at his directory there.
His
so
hard
you really
drive.
did install the software here in a couple of
Yes.
minutes. Adrian, I want to turn to you, and I know Artisoft does software and hardware, but we're focusing here on the adapter and the adapter card and the box you have there. First of all, what is the card?
The card is an AE3 Ethernet adapter, and one of the interesting things about this card is, of course, it's impossible for us to predict what type of cabling our customers have. There are 3 standard types of cabling for Ethernet: thin coax, such as we actually have here in the studio, thick coax, and also 10-base T, which is a new standard that's essentially telephone wiring. So this is the type of device you would actually install in a desktop machine such as we have here.
And if you wanted to upgrade wiring, the card still works.
That's right.
All right, now what's the box for?
Well, in the case of one particular market in the PC arena at the moment, which is that for notebook computers, of course, you don't have a slot in which you can place one of these cards.
Exactly.
So what we have is a product that we call Central Station, which sits on your desk and allows you to connect a notebook computer using a simple cable. When you're finished at your office using your local network, you simply unplug the cable, you take the notebook away with you, and then using this same Central Station device, you can dial in remotely using the modem in the notebook and a modem connected here, and once again you're connected to your notebook from a remote location.
What about the user interface side of this? How do you play with
Well,
this?
one of the things we have to do is to try and make it as easy as possible for the user to make use of the network. So rather than a collection of menu commands or arcane command line options, we actually place a lot of emphasis on using Microsoft Windows. And here, for example, I don't even have a keyboard on the table in front of me, so simply by using the mouse, in order to make network connections, I just point at a resource that I want to use, drag it, and there my D drive is now connected to that new network resource. To disconnect, I simply take it and drop it off the screen.
Certainly a lot easier than it used to be. Thank you both very much. Well, when your company really gets big and you have to communicate with several LANs scattered across the country, you may want to use a public data network rather than create your own. One of the leading systems is called SprintNet.
SprintNet is the largest commercial data network in the world. It is an X25 packet switch network, allowing users to share lines and thus lower costs.
Typically, the big companies previously would say, well, I'll put in my own network, and I'll buy the switches, and I'll buy the circuits, and I'll manage it. They're moving away from doing that. They're saying, gee, do I really have to do that, or why don't I focus on what I do best, which is selling my own products? Now, the little company, it's a natural vehicle for them to go to the public network and say, hey, public network, go ahead and bring my 5 offices together over this public service.
U.S. Sprint's latest technology for data transmission is called Frame Relay Service. The new service will complement, not replace, the X25 system.
Frame relay is the logical evolution from packet switching, because frame relay is taken and built upon the fiber and digital switching capabilities that especially we Sprint have.
The public data network allows companies to communicate with distant offices as often or as infrequently as needed. They pay for only the actual time used, not for the installation of a permanent link between all their offices.
The ideal here is that you can mesh large networks together. So I have offices in maybe 100 different cities, and I can say casually mesh some of my offices together and intently link other offices.
While frame relay technology may seem to be out of the reach of personal computer users, Pfeiffer expects frame relay boards for PCs to be available as soon as next year. For the Computer Chronicles, I'm Maria Gabriel.
All right, so maybe SprintNet is more than you need, but if you've already connected your individual PCs into several local area networks, the next step is to interconnect those networks. Here to show us 2 solutions are Midge Barry of Newport Systems and Margaret Foley of Microcom. And back with us, Frank Derfler of PC Magazine. We talked about the Bible you wrote on connectivity. It's thick enough to be a Bible.
Absolutely.
This is it. Comes with discs, the whole answer. I've got one answer I want from you. We're going to talk about the interlinking between LANs now. And there's the term bridge, there's the term router. What is the difference between those two before we get going?
Both bridges and routers are communications portals on the local area network, but they function in a slightly different manner. The bridge moves data across an inter-network link based on where it's addressed to. A router is much more sophisticated. It looks inside the packet and makes decisions based on information it finds there.
And can route that information based on what it finds. All right, let me go through the physical setup here, because since we're LAN to LAN, we've got 6 machines here, and over there you'll see we have 3 computers. Actually, 2 of them are forming one of the LANs. The third machine we see over there is actually a piece of a network that'll be talking over a wide area network to this machine over here, and we have 1 LAN and that other machine over here. Let's start with you, Margaret, and you've got a couple boards there in front of you. What are they?
These cards are our 16 meg token ring card. We also have a wide area network card. The interesting thing about these cards is they all have a 68,000 dedicated to them. For the LAN card, we have a 68,000 dedicated to filtering packets off the wide area network link. For the wide area network card, we have a 68,000, and we have a compression algorithm, a hardware compression algorithm, which allows us to do compression all the way up to T1, E1 speeds.
All right, now tell us what's going on between the 2 systems we have here, and show us some of the things you can do.
Well, what is actually in those platforms is it's our Ethernet card, which is at 10 meg, and also a wide area network card. Our system is very flexible. You can have a 3-port local bridge. You could have a 1-port with 4 wide area network connections for possible growth. If someone had a hub site, they may want all 4 WAN cards.
Quickly show me what's on the screen here and what you're doing.
This is actually our bridge router. This shows you the Ethernet packets forwarded and packets received.
So this is really how you can monitor what's going on here.
Right, in your network. This shows you the alarms that you've seen on your network. And as you can see, most of the alarms were for port forwarding and topology change detected, which means the link has come up.
Yeah. All right, Frank, I want to go back to you. She, of course, said bridge router, making your point that you're never quite sure which it is. Margaret also talked about compression on the board. What is the value of compression in this interLAN situation?
Well, keep in mind that the links that you use, the commercial communication circuits that you buy to link local area networks, are very expensive. Both of these products have onboard compression, in many cases giving you 4-to-1 or even greater compression, so that instead of buying a circuit listed at 1 megabit per second, you might buy one at 250 kilobits and save a lot of money.
Yeah, okay. All right, Mitch, let's turn to you and tell me what your setup is here, and explain the boards you've got in front of you.
Well, Newport Systems Solutions makes wide area network routers exclusively. This is a wide area network router card. Mostly it's a communications interface card that would actually install into a NetWare file server or a NetWare external router. It looks just like a LAN card to NetWare. And this little module on here is Newport Systems' own data compression module. We too recognize how important data compression can be. Because we can use our products in a file server, I've actually set up the router here in this NetWare 311 file server. And it's communicating to a file server over here on the other table. That should be a remote location. One of the things that we've been seeing increasingly in even NetWare environments are the uses of different kinds of communications protocols. And this screen on the station here, this file server, might look familiar to people. I've actually got AppleTalk protocols and IP protocols, in addition to Novell's own protocol loaded on the wide area network router. Using these different protocols, I can come over to this DOS machine and run a well-known application called Ping, which transmit TCP/IP packets from over the wide area network link. And I can do this at the same time as I'm transferring AppleTalk packets to the Macintosh that we have at the other location. The server at the other location, you can see there's network activity
so we're
on that
talking
server.
over to the other system, which is over there.
Exactly, and we're doing this at the same time, different protocols, and this reflects something
to
that
the
we're
Mac
seeing a
and
lot.
to that PC.
Yes.
Okay, now what else can you do here? What's on the screen we're looking at?
Well, this is simply AppleTalk console. This is a function of Novell's file server where they can actually play games with the AppleTalk protocols. We're using it to show how we can actually transport this capability onto our wide area network product. So this is something that previously was only available in local area networks with Novell. Now we're letting people do it with the wide area networking with Novell.
Mitch, Margaret, Frank, thank you very much. All right, we'll be back in just a minute and show you how to log onto your network by telephone. Stay with us. The ultimate network is one that you can access from anywhere, whether to use files and applications or to do inter-network email. Joining us now with more connectivity solutions are Steve Abdallah of CC Mail and also with us George Lasik of J&L Information Systems. Steve, let's start with you. And the most common application on networks is, of course, email, people communicating with each other. And your program, CC Mail, makes it easy to do that, as I understand it, from virtually any platform to any other platform?
That's right.
Show us how it works.
Okay, we're in CC Mail for Windows here, and in the center of the screen we have our inbox with messages that have been sent to us. And at the top of the screen we have the traditional pull-down menus. We also have an icon menu, which has your basic mail commands right there. And if we want to say prepare message, we just click on the prepare icon, and that launches us into a addressing screen. We just start typing the name of the person we want to address to. We notice here we've addressed to Diane Braga, and she's a Macintosh engineer. And despite the fact that she's on a Macintosh, or she could be on an OS2 or a DOS platform, we can still reach them all, even though we're in Windows here. Add another user, and this user is on IBM Profs in France, and that's a mainframe-based mail system. But with our gateway product, we can connect to virtually any mail system in the world. So we'll enter him. Then we can address it to a mailing list. So this will go to a group of people. In this case, we'll send it to the Novell MHS users. And we have a gateway to Novell MHS. We can also run virtually any network operating system. So we're finished addressing. We type our subject, and then move down to the text. And we can actually insert information from the clipboard here. So we'll paste in some information on CC Mail, and then we can attach any file. We can search through our drives and attach files, so it makes it easy to share work with anyone across the network. Or we can even launch another application and create a new file from within CC Mail. So let's click on this, and it will launch us into Paintbrush, a graphics package. And now we can take and create a little file and then save that. And it automatically attaches to the message that we've created. And then we just quit out of this application and name it, and it attaches to our message, and it appears right here.
So there's an icon.
And then when the person receives it, they can just click on that icon to look at it, and then we just send it.
Okay.
So that's sending a message. Reading a
show us
message
receiving.
is just as easy. Here's our inbox. If we want to read the first message, we just double-click on it, and it opens it up. And here's the text. We've also got a couple of graphics applications here, and we double-click on this, and this is from a CAD package of some kind, and we can even zoom in on the graphics. And we don't have to have this application. We can still view the file even though we don't have the application.
Now suppose I'm in an application and I decide I want to send a piece of it.
It's very easy to do. CC Mail is can mail-enable applications, and so we can go into AMI Pro, a word processing program, where we've created this file right here. And if I want to send this, all I do is come over to the file mail and say, send mail, and this calls up CC Mail. I attach this file, and it calls up the CC Mail addressing dialog, and I can type in a short message in the text and attach this to the file, and then I can call up the addressing screen and send this to anyone else on the network.
Steve, thank you very much. All right, let's sort of up the ante one now. We sell email almost anywhere to anywhere. You can do anything anywhere to anywhere, I guess, with the Chatterbox. First of all, George, describe what the physical configuration is here.
Okay, very briefly, the unit to your left is a PC. I'm in the process of doing something, but I'm doing it remotely through a telephone line to another network.
Okay.
To my left is the actual network running in a Chatterbox, as well as the access server for the network, and that's shown by the Chatterbox 4000, which happens to have 4 computers inside of it.
Okay, show us what you would do here then.
What I'm going to do is I'm going to simulate first the failure of my modem, which is very important. And in doing it, you'll turn off the modem.
All right, so in the middle of work and your system dies.
And our proprietary circuitry will sense this and automatically reset the Chatterbox so that somebody can't get in immediately and do work or find something that's sensitive. Now I'm going to reconnect one more time.
Okay.
And this is the way we do it. And as it's connecting, what this is going to do now is I'm going to run a program which is going to disable the Chatterbox processor, which represents the conflict of software that's running in untested mode or other programs.
TSR or something?
TSR is propping into each other. And what often happens is the processor self-locks up. I'm going to simulate that by causing that computer lock up, and then I'm going to reset the computer remotely from here by shutting off the connection, and you'll see it again.
So the computers are trying to connect right now.
They're talking right now to each other, waiting for them to establish the proper baud rates to work at.
Okay, so they're on.
And here we are. And I'm going to log in one more time.
Okay.
Again, I'll come in as a supervisor. And this is a standard login with all the security offered to a remote user. I'm going to run a very simple program, and here it is. And as soon as I do that, the processor in the chatterbox is completely dead.
Yeah. So you've simulated the other end dying.
That's correct.
And you can't do anything with it now.
That's correct. So what I'm going to do is I'm now going to bring up this, which is the, it'll take a few seconds because it's still trying to talk to the computer. And I'm going to bring up the screen to tell the other unit to reset.
Okay.
There we are. And I'm saying, do I wish to disconnect? And I'm saying yes. And what happens now is the other unit is resetting, and you'll see this happen. My friend here, Rex, is going to shut off the other modem, and that's going to simulate yet another type of failure, which is a failure of the processor. And I'm going to call back 1/3 time, and you'll notice that when I do, the modem is going to find that the other one is busy, and that's the proprietary busy circuit, which keeps the line busy so that you don't have people calling into malfunctioning modems or malfunctioning processors.
And it gets a busy signal which protects you.
Gets it busy, and it keeps everyone locked out so you don't have a processor that's out of
so I guess the point in Chatterbox is not only to get anywhere around the world, but to really have a secure system so the wrong people can't get anywhere around the world.
It provides absolute security, that's correct.
George, thank you very much. That is our look at connectivity. Stay tuned now for this week's computer news on Random Access.
In the Random Access file this week, this is a special summer edition with a focus on software. Here are last week's best-selling software titles for the PC, according to PC Connection. Xtree for Windows occupies the #1 spot, and rounding out the top 10 are Microsoft's Windows 3.1 upgrade and QuarterDEX Expanded Memory Manager 386. Next up, Paul Schindler in our summer software review.
There it is, one of the simplest visual cues known to man, the traffic light. Now, the fact that information can be communicated visually escapes a lot of people, but not the people who made ManagePro. This Windows software manages people, and what do managers want to know? What's wrong? So ManagePro offers status boards. Green means fine, yellow means caution, red means something's wrong. Double-click on a box to find out exactly what's wrong. You can look at goals on a status board too. Just click down to get the gory details. You can also view your goals along a timeline or as text. Now, most people don't use project management tools because they're too darn complex. ManagePro isn't really a project manager. It's a people manager so simple an executive can use it. It costs $400 from Avantos Performance Systems in Emeryville, California. For the Computer Chronicles, I'm Paul Schindler.
That's it for this week's Computer Chronicles. I'm Janelle Stelson.
Computer Chronicles has been made possible in part by PC Connection and Mac Connection, mail-order software and hardware peripherals for the PC and the Macintosh, and the Software Publishers Association, providers of educational materials to help manage software. Don't copy that floppy.
Videocassette copies of this program are available. Computer Chronicles also publishes a companion newsletter containing details on products demonstrated, plus background information on program topics. To order a videocassette or a subscription to the newsletter, call 1-800-366-9484 or write Computer Chronicles. Please specify program subject for tapes. All orders include a free software program for auditing software use.